Welcome. What I want to do today is show you how to solve this equation. N minus 5 is equal to the square root of n minus 3. So what we need to do for this is we need to make sure we isolate our variable. And you can see we have a variable n on the left and on the right side of this equation. So what I'm going to do is I'm going to have to get them on the same side. But before I do that, I want to get rid of this radical. All right. So when we think of inverse operations, you know, the inverse of adding would be subtracting. The inverse of multiplication would be division. So the inverse of square rooting would be to square. So we're going to have to square both sides. And it's very important to make sure that when we square both sides, that we need to also make sure that at the end we're going to have to check for our extraneous solutions, which we'll talk a little bit more about when we get there. So here, n minus 5 squared, I'm going to go a little bit quicker. N minus 5 squared means n minus 5 times n minus 5. So if you want to do this, you know, write on a sheet of paper real quick. You can multiply that out by using any kind of method. But I'm just going to kind of work a little bit closer here. That's going to be n squared minus 10n plus 25 equals the square root. Squaring the square root is just going to provide us this n minus 3. Now it's very easy for me to get these on the same side, because now to solve for this, I'm going to have to look at this and I'm saying, well, I can't just isolate my variable. I'm going to have to use a factoring technique. So I'm going to subtract the n and add the 3 to both sides. So now I have it as n squared minus 11n plus 28 equals 0. Now it's important for me to get it to equal 0, because then what I can use is my factoring technique, and I can also use the zero product property to help me solve the problem. So what I'm going to do is I'm going to say, is this factorable? And actually it ends up working as, yes, this is factorable, into n minus 7 times n minus 4 equals 0. All right. Therefore, I can say that my two solutions are going to be n equals 7 and n equals 4 when I use the zero product property and set them both equal to 0. Right? Let me just go and show you real quick. Guess I might as well make sure we're all on the same page. So therefore, since I have two numbers multiplied to give you 0, I can say n minus 7 equals 0 and n minus 4 equals 0. Right? Because whenever two numbers equal 0, we have to set one of them has to equal 0. So therefore, I can say n equals 7 and n equals 4 are my two solutions. Now, since I squared these both sides, I got to make sure I check these for extraneous solutions. Do these make sense? So I can plug in the first one. So I have negative 7. You're just going to plug them into the equation. Minus 5 squared equals the square root of 7 minus 3. And that was my, no, not squared. It would just look like that. Right? Okay, well 7 minus 5 is 2 equals 7 minus 3 is going to be the square root of 4. Now remember, the square root of 4 can be plus or minus 2, right? Well, 2 equals, plus or minus 2. Well, we know it can't be a negative 2, because if I had a negative 2 in for there, negative 2 minus 3 would be a negative 5. We can't take the square root of negative 5, so it would have to be that positive value. Since 2 equals 2, we're good. That is going to be a solution. So therefore, I can say 7 is going to be a solution. Now let's check 4. So I say 4 minus 5 equals the square root of 4 minus 3. All right, so therefore what I have is negative 1 equals the square root of 1. Now again, remember, this could be plus or minus your square root of 1. So negative 1 equals plus or minus 1. Well, be careful though, because let's say if it was negative 1, that would work, but negative 1 minus 3 would give us a negative 4. We can't take the square root of negative 4. Then let's say what if it was positive? Well, even positive 1 minus 3 would still give you a negative number. So therefore, this is not going to work. This is going to be an extraneous solution. So therefore, the only solution for this problem is going to be our number 7. All right? There you go. Thanks.